All right, so these kinds of questions can be real mind benders and just really hard to try and follow along with what they're asking you to do. So hopefully what I'm about to show you is something that can help you kind of make sense of this. So we want to convert this into an equation. And at first that might not sound like it's going to be a helpful thing to do, but maybe as we go through it, maybe it will help to click a little bit. So it says 8% of 60 is 1/5 of one number. And that is, like I said, just kind of a strange thing to work through. So first thing we want to figure out is this number that we're solving for is our variable. It's this unknown. So I'm going to replace this with or instead of what number, I'm going to replace that with x. So 8% of 60 is 1/5 of x. Okay, and we're trying to figure out what x is. Now, the other thing it's helpful to remember is that anytime you see is, that is another way of saying equals. So 8% of 60 equals 1/5 of x. So already we're kind of turning this into an equation. So now I'm going to turn this into 8% times 60. And when we say 8% of 60, that's another kind of thing that we need to keep in mind. 8% of 60 means 8% times 60 equals 1/5 of x, which is another way of saying 1/5 times x. So now I'm going to rewrite this just a little bit to make the math look a little better. So instead of 8%, I'm going to put 0.08. Hopefully you know that 8% means 8/100ths times 60. Oops, not 80. 60. And then instead of 1/5 times x, I'm going to put x over 5. I just moved the x up into the numerator, and that's something we're allowed to do. So now this is a pretty straightforward equation, and this will give us our answer. So if I do 8% times 60, you can plug that into your calculator, or 0.08 times 60. That's going to be 4.8 equals x over 5. And now I can do the final step here, which is just to multiply this times 5, which means I need to do the same thing on the right. And those 5's cancel out. I'm left with x equals 5 times 4.8 is 24. And again, you can plug that into your calculator, double check. But just by turning that kind of confusing arrangement of words into an equation, hopefully, again, you followed how we did that, it makes it a little simpler. So hopefully that was helpful. All right, so we're going to be looking at our final transformation today, rotations. And once we are done with today, we are going to be good to go. Oh yeah, sorry, just lost my train of thought for a second. We're going to be good to go with having all the coordinate rules. You're going to be able to use those in any situation. So remember, there's already a reference on the Canvas page, and I might pull that up again, but I've already shown it to you. So don't forget about that. So you don't have to copy down any of the coordinate rules we come up with today, but we're going to be looking at rotations. And we're going to talk a little bit just of some of the conceptual stuff about rotations, and then we're going to go on to Delta Math today, and I'm actually going to teach you using their website. So rotations. Here's a few things to know. We were going to rotate a figure. In our case, we're always going to rotate about the origin. That's another way of saying we're going to rotate around the origin. So you'll see that word used sometimes. The origin is 0, 0. Don't forget that. And that is called the center of rotation. So we're going to have our center of origin be right here. So if I have a triangle that I'm going to rotate, I want to rotate it around this point. And I'll work on that a little bit more in a second. So the other things we need to know where we rotating around. The other thing we need to know is what is the angle of rotation? What's the direction of rotation? Now we could rotate lots of different angles. I could say rotate 30 degrees, but that gets really complicated. So we're not going to focus on rotating 30 degrees. We're only going to be focusing on rotating multiples of 90. So you will have some 90, 180, and 270 degree rotations, which again, we will talk about in Delta Math, but I might tell you to rotate this to right here. That's 90 degrees. If you follow that, that's 90 degrees. And the thing is, if I just told you to rotate 90 degrees, that's not necessarily going to help you a whole lot. You need to know which direction are we going, and the two directions we have are clockwise or counterclockwise. So you'll always be given instructions to say rotate 90 degrees clockwise or counterclockwise, or 270 degrees. I don't know why that's hard for me to say, clockwise or counterclockwise. And if you ever forget what clockwise or counterclockwise is, if you just picture a clock and try and remember which direction, so the second hand is going around in this direction, right? So if you need to pull up a picture, whatever you need to remember which direction clockwise is, there you go. All right, so those are just some generic things that we need to remember. And now we're going to go over, and actually we're not going to do that yet. I'm going to have you do that later, so don't raise your hand currently. Okay, let's go over to Delta Math. So for the rest of this, we are going to be looking at this screen, not this though, not yet. I'm going to rotate a figure about the origin, and it's guided. So this is going to be problems like this on your homework, and we will go through this. Okay, so it's going to be a little bit confusing perhaps at first, because there's the way that they do it online is different than how we would do it in class. And there are some ways that make it a little easier if we were actually sitting in class and we had different ways of doing a 90 degree or 180 degree rotation. But regardless, we are going to do it online. So here's the way that they like to do it. You're going to start, it says draw a circle centered at the center of rotation, which is 0, 0, such that one of the vertices of the figure is on the circle. So that means I'm going to drag this circle. Notice I can create this circle now. I'm going to drag it so that it lands on one of these vertices of these figures. It doesn't matter which one we pick. So I'm just going to pick this one right here. All right, so that's the point that we are using. And I'm going to go ahead and, sorry, it says for the next step to take this yellow dot in the middle and drag it so that we have a line that goes through the center and through the vertex. So if I just connect it right there, it's the point that we originally selected for our circle. We're going to make a line go through the center and that point. Now this is the point that gets a little bit confusing because it asks you to draw a perpendicular line. And so if I draw one that's approximately perpendicular, it might not be correct. So I'm going to show you how you can find the correct point without getting into all the mathematics of it. We'll worry about perpendicular lines at a later date, but this is just going to be a really quick and easy thing. I want a point that's approximately 90 degrees away. So I'm going to draw, remember perpendicular means that they intersect at a right angle. So I want to draw an approximately 90 degree angle. So it's somewhere in this range, I don't know. But what we're looking for is where does an actual point fall in the circle? And notice right here, if I move this away for a second, right here, that is an actual point on the circle. And it also looks to be about 90 degrees. So that looks really good. And for right now, we're going to call that good enough. We'll know if we did it right because there we go. It accepted that line. It said it was the perpendicular one. It would give me an error box if I made a mistake. So we'll do this a few times just to make sure it makes sense because this is a lot to do. And then it says rotate 180 degrees. So every single one of these lines coming out represents 90 degrees. So here's 90 degrees clockwise. Here's 180 degrees clockwise. There's 270 degrees clockwise right there. And then there's back to 360 degrees. So 90, 180, and I'm going to stop right there. And I'm going to animate that so we can see the rotation happening. There it is. Sometimes that can be helpful. In a minute, we will look at that again. But I'm not going to worry about these points right now. I'm just going to come up with a new problem. We'll go through that process again. And you are going to be doing this on Delta Math. So make sure you're following along and you know how to do it. So I'm going to draw a circle. Remember, the first step is to draw a circle that goes through one of these points. I'll go to the furthest away point this time. But again, I could pick any one of the vertices of this shape. Now it wants me to draw a line from the origin to that point. So I'm just going to connect those two, and I'm done. Now is where I need to draw the perpendicular line. And here's where I want to find the line that's approximately perpendicular that passes through a point. So right here, I'm already thinking it's going to go through that point right there. And we'll see if that looks right. That looks right to me, and it accepted it. So I'm not doing any calculations for this. I'm just kind of approximating where it is and looking for a point that falls on the circle that goes through one of these intersections. Okay. So now it tells me to go 90 degrees clockwise. So I need to think clockwise is going around in this direction. And 90 degrees just means to drag this red dot over to the next one. And I'm going to call that good. Okay. So I will do the next step. I'm going to pull up another problem that only has 3 points, just so we don't have as much to write down. There we go. It's a triangle. Okay, so let me do this process one more time. I'm going to go to the closest point this time. And I'm going to do it a little bit faster now. So connect the origin to that same point. Draw a perpendicular line that looks like it's going to go right there. Yep, that was it. 180 degrees clockwise. There's 90 degrees clockwise, 180 degrees clockwise. And that's it. If it leaves you like that, then that means you did it correctly. Otherwise, it'll give you an error box. So anyways, I can animate that just to see the rotation happening. Very good. So now I want to figure out, where did these points start at and where did they end at? All right, so in my pre-image, and this is where it's helpful maybe to watch this animation. So here's my point, 7, -6. That's 7, -6. It's this point right here at the bottom. I'm going to animate that rotation, and I'm going to see, okay, so that went all the way up to here, which is -7, 6. So I'll type that in, -7, 6. 7, -2 is this point, and I'll animate that one. So 7, -2, if I follow that point the entire way, it takes me to -7, +2. And lastly, that means this point got rotated to here, and that was -4, 2. And I'll just submit that answer, and there we go. It's a red or a green check mark. So if that makes sense, you're going to do a few problems like that just to understand the idea of the rotation. This is going to give you a good visual for that. So I want to come up with a new problem. Hopefully it's a, okay, I don't want to do a pentagram. Nah, I'm trying to do it with fewer. No, I can do it this way. All right, I don't want 180 degrees. Sorry, I'm looking for a specific type of problem. It doesn't matter. Here's 270 degrees, but let me do a 90-degree clockwise triangle. Okay, we're good to go with this one now. Sorry about that. So I'm going to do this rotation. So you get to watch me do this fun thing again, but I'll be very quick about it. 90-degree clockwise. So we've already done 90 degrees. This is going to go clockwise. It's going to end right there. Now I am going to copy these coordinates again, but what we're going to do differently is this time we're going to try and come up with the coordinate rule for this. All right. So our coordinate rule, this point of 4, -6. 4, -6 got rotated around to -6, -4. Again, I'm taking this point right here and rotating it around to that point. 6, -2 is this point, and it rotated around to this point right here. So that's -2, -6. And lastly, this point rotated to here. That makes that 4, -2 became -2, -4. So I'll try those values. Now this is correct. It says I'm correct. And what I want to do at this point is I want to look at my results and figure out what my coordinate rule is. And I'm going to call this coordinate rule R of XY. And can anyone kind of describe what happened to our points? And what I want you to do is look at these X coordinates and see where they ended up. Are the X coordinates still in the front, or did they get moved to our Y coordinate?
They flipped.
They flipped. In fact, you can see really quickly that the coordinates flipped completely. So the -6, -2, -2 is now up at the front. So that means that this Y value actually got moved up to the front. The X value, 464, that got moved to the back. And that's what we're looking at. Now, there's more to it. I know you guys can see that. I just want to clear this real quick. When we moved these X values to the back row, to the Y coordinate, what did we do to it?
Turned it negative.
There we go. We changed the sign on that. So not only did we move the X from the X coordinate to the Y coordinate, but we also changed the sign of it. So this is the coordinate rule for going clockwise 90 degrees. And I'm going to write that out real quick. 90-degree clockwise rotation. And I can kind of put a box around that. You don't have to copy this down right now. If you want to, you can, but this is on that reference page on the Canvas classroom. So you're in good shape. All right, so what we can do is I could give you a random point. I'm going to say, let's find a 90-degree clockwise rotation of -8 is 7. And without even seeing a graph, we can do this. I can tell you where this is going to end up because I'm going to flip the coordinates. First of all, XY becomes YX. So remember, you can also think of this as just plugging in. Whatever your X value is, I'm going to plug it in wherever I see an X. So my Y value is 7. It gets plugged in for Y right there. So 7 goes right there. And then the -8 is going to get plugged in for X. So it's -8, which tells me just to change the sign of it. So it's 7, 8. All right. And that's really all there is to it. Nothing super complex, but it is a little bit tricky when you have to flip and change a sign, and it can be confusing. So you're definitely going to want to get some practice with this. All right. Let's look at another one, unless there are any questions. Okay. There's one other thing I need to think about. So if you do have questions that come up, we're actually not leaving the page just yet because we need to talk a little bit about a 270-degree rotation. We actually haven't seen one of those yet. So this was just rotated 90 degrees clockwise. So that's a 90-degree clockwise rotation. Now, 270 degrees would be if I kept going. So every single one of these that I do, so I'm going to go in the other direction now. That's 90 degrees counterclockwise. That's 180 degrees counterclockwise. And that's going one more. That's 270 degrees counterclockwise. So it turns out that 90 degrees clockwise is the same thing as 270 degrees counterclockwise. And that's going to be important to know because I really only label these rules as 90-degree rotations, but this is equivalent to 270-degree rotation counterclockwise. So we'll see that when we do the other rotation, that the 90 degree in one direction is equivalent to 270 degrees the other. But hopefully that point is making sense to you. And that should also click because if you go a full 360 degrees, you get back to where you started. Well, the 90 in one direction and 270 in the other, if I add those two up, 90 and 270 is 360 degrees. Okay, so this is 90-degree clockwise rotation. We'll summarize this at the end. All right, let me pull up a new problem. And actually, at this point, this is where I want you guys to raise your hand. There we go. Everyone's paying attention today. Great job. Okay, raise your hand if you didn't already. All right, so, and if you don't know how to raise your hand, you can go ahead, do a private chat to me, whatever works for you. So we just did a 90-degree clockwise rotation. I'm going to say 180 for last. I don't want 3 points. Oh, man, I just had a 90-degree counterclockwise. There it is. This one works. 3 points, 90-degree counterclockwise. This is going to be a different type of rotation. So let me run through the process again. You'll get to see this enough where hopefully this is really, really simple. Connect the origin through the point, make your perpendicular line. 90-degree counterclockwise is going to be going against the direction that a second hand would go. So there we go. I'm going to copy these points over. So this point right here, -2, -2, is now at 2, -2. Let's see, -3, -8. That's the one where I put my circle. So that's going to end up on the circle again. That's at 8, -3 now. And we've got -7, -7 becomes 7, -7. So we are correct. That's all good. And the same sort of thing is happening here. In fact, we're going to see that a counterclockwise rotation, so let me write that in, 90-degree counterclockwise rotation is going to look very similar to the 90-degree clockwise rotation. So I'm going to call this one L of XY. And we want to kind of generalize what happened here. So I had 7, 3, and 2, -7, -3, -2. And we can see that those, I'm just going to go through this somewhat quickly. Those got moved into the y coordinate, -7, -3, -2. So my x value got moved to the back. And, oops, I wrote that wrong. It got moved to the back and it did not change sign. So it's just exactly the same. It was negative to begin with. It was negative when we're done. Nothing changed. The y values started right here as -7, -8, -2. I brought them up to the front. And I also changed the sign of them. Instead of -7, now they're positive. So that means I actually changed the sign. So just as a reminder, when we put -y right here, that doesn't mean we're going to end up with a negative coordinate. That means we're changing the sign of whatever was there to begin with. So this is our coordinate rule for this one. And just as a reminder, this is equivalent to a 270-degree rotation that's clockwise. So if you're asked to do a 270-degree clockwise rotation, just think that's 90 degrees in the other direction. And I'll go ahead and put a box around that. So now if I gave you a generic point here, I'll say 5, 8, whatever. I'm going to do this coordinate rule to it, which means first of all, I want to flip the coordinates. So 5, 8 becomes 8, 5. And secondly, when this y gets plugged in, it's getting plugged in and changing the sign of it. So the 8 becomes a -8. Now, if I plot that up here, let me erase this, just to make sure that it looks right. 8, 5 is going to be about right here. And when I do a counterclockwise rotation, -8, or sorry, that was 5, 8. I'm sorry, I should get it right. So it was at 5, 8, which is right there actually. This becomes -8, 5, -8, 5. And yeah, that looks like I went 90 degrees counterclockwise. So there we go. Very good. Don't know if you guys need to see more about this, but a 90-degree counterclockwise rotation, just to show you, is the same as going 270 degrees clockwise. Okay. If there are any questions on this, please stick around. We're not done yet, I should mention, but don't leave confused on any of this stuff. So we can go through more examples and you can ask whatever question helps. So let's find a 180-degree rotation. 180, I don't want 5 points though. Dang it. So it'll just take me a second to load one up. Why does it keep doing 5 points? And I can't seem to get this to stick. 4 points, fine, we'll go with that. Okay, so pick a random point. I'm gonna rotate based on this point. There's the line going through it. Here's the, nope, yep, that's the 90-degree angles. Because notice that one looks like it goes through, but I can see that's not quite 90. That one looks better. And that one worked. 180 degrees, it says clockwise, but here's the thing, 180 degrees doesn't matter if I go clockwise or if I go counterclockwise, because I'm gonna end up in the same spot regardless. So when it's 180 degrees, the direction doesn't matter. All right, so let me copy down the new points. So -4, -8 is this one, and that ended up right here, 4, 8. -2, -5, which is this point right here. That ended up right there, which is just 2, 5. And you can already see the pattern happening, I hope. -4, -5 is the point that actually rotated based on. So it's going to be this one right here, which is 4, 5. All right, we should be able to do the last one without even looking, but I will. -8, -3 rotated to here, which is 8, 3. And this was correct. So this I'm going to call C. This is 180-degree rotation. And this is going to be C of XY. So what happened to our coordinates when we did this? Does anyone see the pattern that developed here?
Both of them change. Like both of them go opposite.
There we go. We just changed the sign of both of them. We didn't flip the order. So X becomes -X, Y becomes -Y, and that's it. That's our coordinate rule. I'm going to put a box around that. So just to wrap this up, if I had 5, I don't know, -12. Let's do something like a bigger coordinate. So all I need to do when I do a 180-degree rotation, it's going to be -5, +12. I'm changing the sign of both of these. So a 180-degree rotation is actually maybe one of the easiest coordinate rules to use, but you have to know which one to pick. So that is what you've got going on. And I'm going to show you the other type of thing that shows up in your assignment today. And then we're basically done at this point, but don't leave yet. So here it's going to say, what is the image of the point 6, -2 after a rotation of 90 degrees counterclockwise? There's no graph on this one. We just have a point and a transformation to do. So I want to remind you that R of XY gives us Y -X, L of XY, and this, I'll label these better in a second, is going to be -YX, and C of XY is just -X, -Y. These are our three. Now you don't know what the R and the L and the C, but this is your 90-degree clockwise. This is 90-degree counterclockwise, and this is 180-degree rotation. So I just want to, and since this is on your cheat sheet that's online, you don't have to have it memorized. You just need, and it is labeled with the 90-degree clockwise and counterclockwise. So at this point, all I need to do is pick the correct one. 90-degree counterclockwise is this coordinate rule. So I'm going to do L of 6, -2, which tells me, in this case, to flip the coordinates and change the y value sign. So when I bring that -2 up to the front, I'm going to change it to +2. And when I put the 6 at the back, it just stays 6. 2, 6. Let's see if we did it right. Yeah, we did. And even if you got it wrong, remember there's a reminder right here. So it shows you how to do it. And it even goes through step by step a little more than I did. So that is your homework. The last thing I might point out is I will just move over to the Canvas page to show everyone one last time where that cheat sheet is in the modules. All right, so it's a coordinate rule reference sheet. And here it is. These new rules are added. So I will clear the screen so you can see it. Okay, that's just about all there is. We've learned all these rules. Now we're just going to spend a few days practicing how to use them and using them in different ways. All right, if you have any questions, stick around, but otherwise you can have a wonderful day. I will see you guys tomorrow, and good luck.
Thank you. Have a good day.